All right, so day 1 of Exponents is geared towards writing and evaluating powers, with also being able to answer the question of how can you use exponents to rewrite numbers. By the end of this lesson, you guys should be able to write, evaluate, and answer our essential question. Please make sure as you continue on that you do have a piece of paper along with a writing utensil to take notes throughout the lesson. Let's first start out with understanding some key vocabulary. The first word on our list is power. A power is a product of repeated factors. Within our diagram below, you will notice that the power is this entire picture. 1/2 to the 5th power is what we call the power. It is a product of repeated factors, which means 1/2 is used as a factor 5 whole times. The second word we're going to talk about is base. The base of a power is the common factor. In this case, our base is 1/2. 1/2 is the factor that we are going to multiply by itself 5 times. So in this case, our base here is considered 1/2. The third word we're going to talk about is exponent. The exponent of a power indicates the number of times the base is used as a factor. So in this example, our exponent is 5. It basically means that we're taking our base, which we already said was 1/2, and multiplying it by itself 5 whole times. In this case, I can rewrite my whole power in expanded form by saying 1/2 times 1/2 times 1/2 times 1/2 times 1/2. I've taken my base, which was 1/2, and used it as a factor 5 whole times to write my power in expanded form. All right, now that we've talked about some key vocabulary, please make sure you have it available next to you because I will be referring to this vocabulary throughout the rest of the lesson. All right, so now that we know some key vocab, let's get into writing expressions as exponents. So our first example here says to write each product using exponents. Our first example here is -7 times -7 times -7. It's important to note here that our base is -7, and -7 is being multiplied by itself 3 whole times. So to write this expression as an exponent, I'm going to go ahead and write -7 in parentheses to the 3rd power. It's important here to use parentheses whenever dealing with negative bases. Without parentheses, if I were to rewrite this expression as -7 to the 3rd power, my base is no longer -7. Now my base here is just a +7. So it's super important to always include parentheses whenever your base is negative. Our second example here is pi times pi times r times r times r. We know the base here is going to be pi. We know pi is being multiplied by itself twice. And we know the base here is r, and we know r is being multiplied by itself 3 whole times. So our entire power here is going to be pi squared times r cubed. All right, now that we've done 2 examples together, why don't you guys go ahead and try to do example 1 and example 2 on your own. Please make sure you include your responses in your notes. Please make sure you stop the video right now because I will be including answers in just a moment. All right, the final answer for the first one is going to be 1/4 in parentheses to the 5th power. The reason that I included parentheses is because you are taking the whole base 1/4 and you're multiplying it by itself 5 whole times. If you don't include the parentheses and you just write 1/4 to the 5th power, now you're saying that the base here is just 1 and you're multiplying it by itself 5 times, which is not what we want, okay? We want the whole base to be 1/4, which we're multiplying by itself 5 whole times. Again, parentheses are super important here, especially with fractions. Our second example is going to be 0.3 to the 4th power, because we're taking our base 0.3 and multiplying it by itself 4 whole times x squared. All right, now that we've done a few examples, now we're going to get into evaluating expressions. To evaluate an expression means to take your exponent and your whole power here and to give a final answer. So for our first example, you're going to note that we have parentheses. Okay, so that means that our base here, and I'm going to write it off to the side, our base here is -2, which means I'm going to take -2 and multiply it by itself 4 whole times. Now we need to evaluate our expression to get a final answer here. So -2 times -2 is going to give us a +4. 4 times a -2 is going to give us a -8. And -8 times a -2 is going to give us the final answer of a +16. You'll notice that whenever your exponent is an even number and your base is negative, your final answer will always be positive. So that's another thing to know. Our second example here has a base of not -2, but this time our base here is going to be a +2. The reason why it is a +2 is because this time we do not have parentheses. All right, in our previous one, remember I had stated that parentheses are important, and this is where parentheses come in handy. So our base here is a +2, which essentially, if I want to rewrite this power in expanded form, I'm going to have negative times 2 times 2 times 2 times 2, which means I'm taking the base of 2, multiplying it by itself 4 whole times to give me the answer of a +16, but because there is a -1 on the outside of our parentheses, we have to apply that to our +16. So our final answer here becomes a -16. So you're going to notice that although these two expressions looked similar, because there was no parentheses in our second one, it actually gives us a whole different answer. So again, parentheses are super important. All right, so I'm going to have you go ahead and try example 3 and example 4 on your own. Go ahead and stop the video, then hit play when you are done, and I will tell you the answer. Alrighty, so our final answer for our first one is, again, without parentheses, it becomes 5 times 5 times 5 times 5 times 5, which will become 625 here. But because there is a -1 on the outside, this final answer is a -625 for number 3. In example 4, again, we have parentheses, so our base here is -1/6 times a -1/6 times a -1/6 here, which is going to become a -1/216. Notice our base here was negative, but our exponent was not even this time, so our final answer was a negative. All right, now that we've talked about exponents and the importance of parentheses, we're going to get into order of operations. So remember, our key little trick here is PEMDAS. Okay, parentheses, exponents. Multiplication and division go left to right, and addition and subtraction also go left to right here. So if for our first example, you're going to notice that the first part is done for you. So they went ahead and they took 3 to the 4th power, and they simplified that to give you 81. Now that you know that that is 81, you can go ahead and go from left to right, knowing that multiplication is first when solving these type of problems. So 81 times 2 is going to give us 3 plus 162. Go ahead, add those two together. Your final answer is 165. In our second example here, again, they went ahead and evaluated the exponents for you. 3 to the third is 27, and 8 squared is going to give us 64. Again here, remember our base is a positive 8. 8 times 8 is 64, and we are subtracting here. So our first step is to divide. So a negative 64 divided by 2 is going to go ahead and give us a negative 32. And 27 minus 32 is going to give us the final answer of a negative 5. Again, you're going to practice examples 5 and 6 on your own. Go ahead and stop the video and then hit play once you are done and you want to check your answers. Alrighty, for our first example 5, we are going to go ahead and evaluate our exponent first because that's the first thing we're going to do. Notice again here our base is a positive 3. So this is essentially negative times 3 times 3 times 3, all in absolute value, divided by 27. So 3 times 3 times 3 is going to give us a value of 27. And because it's multiplied by a negative, it is now final as a negative 27 divided by 27, which gives you the final answer of a negative 1. But because it's in absolute values, your final answer is a positive 1. Looking at example 6 here, we're going to go ahead and evaluate our exponent first. Again, our base here is a positive 2. 2 times 2 times 2 times 2 times 2 is going to give you an answer of a positive 32, okay, times a half, which is going to be our second step here. Negative 32 times 1/2 is going to give you the answer of 16. And then take 9 minus 16, which will give you the final answer of a negative 7. All right, so this is the last slide to the lesson. Go ahead and evaluate each expression A and B. Make sure you save your answers for both expressions and bring them to class with you tomorrow along with your notes. In order to get credit for homework tonight after watching this lesson, go ahead and log into Schoology and complete the Google form response. When you click on the response, it's going to prompt you to a page that gives you kind of some direction on what to do regarding the lesson, along with filling in your name, what period you belong in, the lesson objective, rating how much you understood the lesson, how many times you watched it, and any questions you have for me. Keep in mind, not completing the Google form will mean to me that you didn't complete your homework. So make sure you complete it so you can get credit for doing your homework tonight.